Hello everyone, this question is about vectors. In the diagram, OA, B, C, D, E, F, G is a cuboid. So OA is 2, so this is 2. OC is 4, so OC is 4, so this is also 4. And OG is 2, so this is 2, so this is also 2. And we have IJK direction. M is the midpoint, so midpoint. And the ratio is 3:1. AN is to NB. AN equals 3NB. Okay, so we have to find OM and MN. So the fastest way is to just use this concept. So we're looking for OM, so the direction from O to M. So from O to M, we can just go in this direction from O to the midpoint here, and then from this midpoint to this midpoint, and from here you go up. So this is in the I direction, and the total length is 2, a half of that is 1, so that's why it's I. And this direction is in the J direction, and the total length is 4, a half of that is 2, so this is 2J. And when we go up, this is 2 units in the K direction, so this is 2K. So the factor OM is I plus 2J plus 2K, and this is OM. Now for MN, so from N to N, so we can go from M in this direction, so it's the I direction, and the distance is again 1, so 1I, and then we go down. Going down means the opposite direction of this K here. K is going upwards for positive, downwards for negative. The length is 2, so minus 2K. And for the J, because we know this is the midpoint, and we know this is ratio 3:1, so actually this is also 1. So we do the I is positive 1, the J positive 1, the K negative 2. So that's the MN factor. Now to find the factor equation for the line, to find the factor equation of the line, you can use the point M or the point N. So if we're using the point M, this is 1, 2, 2 in column factors, and for the MN, this is 1, 1 minus 2 in the column factors. So we can just use point M or point M for this factor, and plus lambda times this is MN or NM. Now show that the length of the perpendicular from O to the line is this. So let's start by visualizing by drawing a simple diagram. Let's say this is the line, this is the line equation, and we have this point O, let's say here. We are finding the distance from O to this foot of perpendicular. We're going to call it point P. So we are looking for this length. This length is supposed to be root 53/6. So this point P is on the line, which means, so keep in mind that whenever we don't know the coordinates, we can call it x, y, z, but whenever we want, we can replace the x and the y and the z with 1 plus lambda, 2 plus lambda, 2 minus 2 lambda. Okay, now because it's perpendicular, the dot product is 0, so the factor OP dot the line direction equals 0. The factor OP is the coordinates of P minus the coordinates of A. So x, y, z minus 0, 0, 0, which is just x, y, z, of course. And the line direction is the one with the parameter lambda, so this is the line direction. So when we do the dot product, we simply multiply x times 1, we get x, y times 1, we get y, z times minus 2, we get minus 2z. So that's the dot product. And again, we can replace the x with 1 plus lambda, that is the x, the y is 2 plus lambda, and the z with 2 minus 2 lambda. Okay, now we expand and simplify everything. We have 1 plus lambda, 2 plus lambda, minus 4 plus 4 lambda, so 1 plus 1 plus 4, that is 6, and 1 plus 2 minus 4, that's minus 1, move to the right, plus 1, so the lambda is 1/6. Now since we have the lambda, we can find the OP the factor OP. So OP is again P minus O. So this is the factor. We need to use XYZ, and we know this is XYZ, and the XYZ, because this point is on the line, you can just use the lambda is 1/6 to get the point P. So we replace the lambda with 1/6. So 1 plus 1/6, 7/6, 2 plus 1/6, 13/6, 2 minus 2/6, that's 10/6. So to find the distance OP, we use the square root of the sum of square of each component. So just use a calculator, you will get this value. In case you are wondering why is it not in the form we need to prove, well, just use root 36 instead, and then in the calculator just do 318 divided by 36. In the simplest form there will be 53/6, which is now we have what we need to prove. Alright, I'll see you again next time.